shared a bunk bed for like 9 years. Shared.
Says the older brother.
He's an alumni for his Bachelor of Science here in Electrical Engineering, and he went on to do a Master's here in Biomedical Engineering, studying heart physiology and the MRI. And now that's where I kind of hear in these letters. And then now he started a new PhD program last year in computer science, working with the reinforcement learning and AI group, applying reinforcement learning techniques to some creativity type studies. And then that's one side of him, and then the other side I can give kind of like a comedy introduction. Kory performs Friday nights at 7:30 and 9:30 at the Citadel with the Rapid Fire Theater. He also often has shows on Saturday at Chimprov, which is at sometime 8, 10. They make it up every week.
Time from the audience and then start.
Often on Saturday nights, he and Julian Fade, who's here in the audience, do improvised TED Talks that have kind of a scientific flavor. And he was actually on CBC. Often they also debate on CBC morning shows and here in Edmonton CBC. And even yesterday, I think yesterday morning, he was on the CBC talking about what he did this summer, which was go work for an outfit of Twitter, working on their reinforcement learning group. And he just got back from time in San Francisco. And today he's going to tell us about his work trying to develop a friend that he can talk to.
Okay, give it up for that introduction. That's the best introduction I've had today. Which is awesome. Okay, so I'm Kory. Thanks everyone for coming. I appreciate this. So yeah, today I'm going to talk a little bit about my work that's sort of peripheral to both my improv work and my science work in developing an embodied cognition that I can do improv with. No slight to Julian. He's a good improv partner, but he's not that much fun. Okay.
Wow.
Yeah, so let me tell you, it's a bit of a story. So I'll go through the story. If there's questions that come up throughout, I'm happy to answer those. So here's a younger, much more sprightly me in 2007, along with an improv mentor sticking his tongue out at me. This is Jacob Bannigan, who is a mentor who has given me some great advice along the way in my improv training. Just by show of hands, who here has seen improv before? Okay, who here has no idea what improv is? Okay, great, awesome, then you're in the right room. So pretty much we make stuff up based on suggestions from the audience, and it's all about the dynamic between scene partners on stage. So Jacob said a very interesting thing to me early on. He said, a good improviser looks great on stage, the best improvisers make everyone else look good. And I really like that. I like the idea that it's up to us to make our partners look good in anything we do, science or improv. And I took that advice and turned it into a show that I called 15 Minutes of Fame. So this is me performing 15 Minutes of Fame with a random audience member who's doing a better job acting than I am. You can tell he's got the more natural reaction. September 2013, and we would do shows. I would take a random audience member, the person who had the least amount of experience being on stage, getting up talking, and do a show with them. For 15 minutes, do a live improv with them and try to make them look as good as possible. And some shows went better than others, and this one was particularly good. He was a fantastic partner. But it made me think, anyone see this movie? This classic 1953 flick? It's called Abbott and Botstello Go to Mars. The disclaimer is that no one actually goes to Mars in the movie. They go to Venus, and there's sexy results. So if you want to see it, it's cool. It's the closest Abbott and Costello ever got to like science robots in the future. But it's very funny. So I'm thinking, what else can I improvise with? This is me performing in a soapathon, which is like a 50-hour improv marathon. I'm playing Brother Kierkegaard, who's a neutral priest. Around me is a magician, and this is Adam Megiddo. Adam Megiddo is critical to the story because he is the one who told me something very important. He's from London, the UK. He just recently won what is ostensibly the Tony in London for his work doing an improvised musical on London's West End, which is like Broadway. You got to explain it to some people. So he won a Tony because he brought improv to their Broadway. And he said, I was like, I want to do improv with the AI. I want to do improv with a robot. He says, the first time you do it is going to be the worst time, but everything gets better from there. Every year science gets better, every month the science is getting better, so just start. Just do it every year, and every year it'll start getting better, and you'll be able to make the connections based on just starting. That was very motivating to me, and one of the best beers that I ever bought for someone, because it was really good advice that I was given. So out came artificial improvisation. Anyone know what this picture is an homage to, the play?
Hamlet.
Thank you very much. Enthusiastic participation. It's like you knew, it's like you were showing off. Okay, no, I'm just kidding. Okay, so this is, I started doing research. So 2000, it's sort of cut off a bit, but I started with the classic literature review. I typed in robot improv in Google and found this study. Someone had done it. Done the hard work. This is an and the key name here is Brian McGarrico. Allison Bruce and the rest are team members, but Brian McGarrico is really the brainchild behind this. Pretty much what they were doing is putting hats on robots, two robot actors posing in costume. This is published in a scientific paper, by the way. And this is the believable storytelling. So they have some hard-coded rules, but they also have some like flow chart, and they can sort of move through this flow chart of storytelling with some gates. So it'll make a choice, and then based on how close one robot is to the other, it'll make some kind of contingent choice. So the idea is it's hard programmed, but there's some randomness in it. Cool? So this is Brian McGarrico, very inspiring guy, and he should sound familiar if you know about this like cognition and improv, because he literally wrote the book on cognition and improv. This is just recent. If you want to like really nerd out on this with me, then let's read this together, and we can talk about like how to study cognition with improv and computational models. That's Brian McGarrico, very inspiring. So I'm looking for inspiration. I find Michael Littman. Michael Littman, this is him starring in a TurboTax commercial. The whole idea was it doesn't take a genius to do your taxes. She's sitting here doing her taxes. He rolls in as the genius to fix the taxes, and she's like, no, I got this. And he's like, okay, cool. It's a short segment, but it's him sort of as a scientist representing science to pop culture, and I really like that because he's communicating effectively using his artistic abilities. Michael Littman was here January 2016, and he said, embrace your passion. This is him wearing what is a Google Glass. It's very inspiring to hear a senior scientist say, embrace your passion, because so often we find ourselves working in an academic context where we're grinding on a problem that we're not necessarily connected to. So to hear someone like that say, follow what you're passionate about was very motivating. He connected me then to this guy, Tom Seguros, and this is Tom Seguros performing a show live with a robot named Judy. The show is called Judy, or What It's Like to Be a Robot. It's in 2005 that he does the show. So Michael connects me to Tom, and we start talking about the ideas of what a show could be. He gives me some really insightful ideas. This show was cool, a critical success. This is it back in 2005 when people filmed shows with 300 by 300 resolution. And he had a bunch of buttons hidden around the stage that he could cue the robot with. So he can perform the show and then cue the robot in certain ways. This video is not public on YouTube, and it's fine. It's an interesting show, and he really explores the psychology in performing with the robot while simultaneously performing. The article about this says, if you build a robot smart enough to do the dishes, will it also be smart enough to find the task boring? Find out in this exclusive interview with a robot. This is no joke, the article about his show. He's not very happy about this title, and the article's up to this day, because apparently they had a disagreement. Needless to say, there's a lot of other robots that do shows, stage shows. So this is Carnegie Mellon. They have the Home Butler, and this is like a robotic platform, and Olivia Brown is doing a play with this robot. You can see behind here, hidden in the shadows, there's like a pilot that's piloting the robot around, that's making decisions. So it's deterministic based on how the human is controlling the robot. It's interesting though, because the audience suspends their disbelief and sees the human and the robot interacting. This is obviously a robot though, so maybe more interesting is this show in 2010 in Japan, where Geminoid F which is the robot here, is performing a show with Brierly Long here. And it's a short show called Sayonara Goodbye. It's very, very compelling, very touching, because she's a fantastic actor. So it's this robot is saying goodbye, and she has to sort of act with a robot that's not doing very much acting. But as you can see, it's like compelling that this is a human form that's doing a show on stage with another human. And if you're like, wow, that looks very real, it's because this is the guy that invented it. This is Hiroshi Ishiguro, the robotics developer, and if you're like, man, that guy looks weird, it's because that's not actually him, that's him. And this is him interviewing himself as a robot for a documentary that his robot is making about him. And if that's confusing, it's because this guy is crazy and awesome, and he makes, like this hair is his hair. So if that tells you anything, it tells you that. Needless to say, it should start making you think about something called the Uncanny Valley. So this is the idea that this is human likeness on the x-axis and familiarity here, and the Uncanny Valley is this dip here that makes us totally uncomfortable when we see something like a dead body, or a humanoid robot, or a bunraku puppet, which is like this nightmare-inducing thing here. Tangentially, some of the work that I do in my PhD deals with prosthetic hands, and that's sort of on the upper slope of the Uncanny Valley. We're trying to make prosthetics that look and feel exactly how the wearer wants them to look and feel. Uncanny Valley, very interesting, and it makes us think when we're doing a show or creating a show how we want to best use that. Yeah?
How do you know it's an upslope?
How do we know it's an upslope is a good question. It's the idea is there has to be something up here where we exist
No,
for
I'm
each
asking,
other.
how do you know your prosthetic research and
Yeah.
research is an upslope? Maybe it's still in downslope.
Yeah, it may be, and it's actually very subjective, I think.
Okay.
So if the wearer thinks that it's familiar and connects to it, it may not be that you find it familiar and connect to it. So, subjective human studies. Good question. So, now let's get back to my form. How was I going to put a robot on stage? I'm not a great hardware robot builder, so I needed something that was sort of more virtual. I started researching sort of what existed in the literature, the classical art literature. Pygmalion is a story from Greek literature. He's a sculptor, and he builds this beautiful bride, and then he falls in love, but it's a statue. How tragic. If the story sounds familiar, it inspired My Fair Lady, and that was the source of the name Piggy. So this is me performing with Piggy on stage April 8th, 2016 of this year. So as you can see, my robot, my AI, is just a huge disembodied head that sits behind me on screen, and we can talk to each other. I'll tell you a bit about what is happening behind the scenes for Piggy. So Piggy requires speech recognition. So Piggy needs to be able to hear what I'm saying and maybe what the audience is reacting, how the audience is reacting. And for that I use Google Speech Recognition, an AI, an API that exists in the cloud, and you have to send packets back and forth with internet. It also needs some way to be able to talk. For that I use the Mac. The Mac comes with a whole bunch of great voices, and you can see behind Piggy is this convoluted concoction of two dialogue management systems. One's called PandoraBots, and one is called ChatterBot. This is like a pay-per-use, this is a free use, and they have two different purposes. So PandoraBots was like hard-coded rules, so I could hard-code it and say, like, when I say, let's start improvising, you say, okay. Or when I say, my name is Kory, then you remember that name entity equals Kory. Cool, so it can do variables, but also hard-coded rules. ChatterBot is a dynamic system that learns based on what I'm giving to it. So I'll say something to it, and then it can maybe repeat that, or generate some text based on other things I've said that are similar to it. Cool, so the initial Piggy was based on a sort of haphazard concoction of these two systems, and I'll show you what that means. But first, this is what it looked like for Piggy to talk. So all I did is pipe the sound through the sort of mouth entities and jittered the mouth when there was talking happening. And this was enough to sort of give some sense that the robot was talking and should be focused on. So One of the questions is, now you have these systems, Pandora bots and Chatterbot, how do you train it? How do I give it enough seed information so that we can have a meaningful, unique, specific scene? So the first thing I did as a computer scientist is set up a website where people could like come on and chat with Piggy and it would remember all the conversations. This is great and easy and it would build a chat, but I sent it to all my improv friends, some of whom are in the audience here, and they just harassed the shit out of it. Just like did not treat it nicely, so it ends up with a bunch of bad, and that's like exactly what we saw with Microsoft's Tay. Like as soon as you have the ability to start communicating with these agents, some people will act adversarially to your goals, which is fine, which is okay and totally in human nature. And I don't fault anyone present except Paul.
I gave good talks.
Okay, thank you. No, Paul was instrumental in making this work. But one of the other things that I could do is train on movie dialogue. So there's this great movie dialogue database from Cornell that has a bunch of conversations. I trained it, and then it has some lines from movies. So this is the transcript from that show, and it's interesting. I give it some like seed information, what's in your basket, and then it says something like, I'm a mobile virtual assistant. It gives me a name, what is it, what are you doing, what's happening? At this point, there was a huge reaction from the audience, which is when I started to realize that there was a major fault in the plan because the audience's noise was picked up by the microphone and started to be heard and understood by the speech API. And this was like the cyclone that started crashing Piggy in that moment. And this was after like I tried hard to get the database up and running. Needless to say, it was an okay show, and you didn't miss much. And Adam Megiddo was right. The first time sucked, and the next time will be better. It was also offensive enough to be like, you know, a total AI. It said something like, your queer party friends. But it said some beautiful stuff, like, it had this nice reaction of like, too bad, right? I say, and it says, too bad, right? You can be direct with me, I make maps. Which is like, it's repeating what I'm saying, which is something we do in conversations a lot. We often repeat what other people say and then add our spin on it. In improv, we hear, or one of the lessons that you learn is that if you just say what the person said, that helps you to actually hear it and listen to it before you say it. And then I say, like, as it's failing, I say, well, shit. And then Piggy says, swearing is often cathartic. Perfect, yeah, thanks. Kick me while I'm down. So that was the first one. That was arguably a success because it booted up, it got some lines back and forth. This is obviously a bit cleaned up because the output isn't as clean as this, so I did it for formatting. That's me performing with Piggy. Immediately after that presentation, two amazing people contact me. One of them is Pietro Moravsky. You can find him at HumanMachineImprov. And the other is Arthur Simone, who hosts the Fusebox Festival of Human and Robot Improv, which is something that I didn't know exists in Austin, Texas. Two mad scientists, much like me. I feel like if you like added those two photos together, you would just get a picture of me. So let me tell you a bit about how things grew from there. Just like Adam Megiddo said, as soon as I did the first show, people started contacting me and we could have higher level conversations. Piotr sends me an email May 3rd and it says, I'm working on training in neural networks to create an improv show with a disembodied AI. I would love to chat with you about it. This is like the most exciting email I've gotten for a long time because it's exactly what I want to talk about. I say to him, I have a few problems. First, there's too many connected services. I have Pandora bots and Chatterbot and Google services and the Mac and whatever, and he has an idea. I say there's too many hard-coded retrieval-based rules, so I have to tell it to like repeat sometimes and add the two outputs sometimes. And I also say like there were major tech issues. I had no idea what to do. And Piotr, as good as he is, said, okay, well, I've built a completely offline version based on Apple's dictation and text-to-speech, so you don't need the internet, you don't need any of your shitty connected services. He said, I built a generative model based on novel research in NLP, natural language processing, and deep neural nets. And we can combine the two ideas. And he said, and I was like, I got tech issues still. And he's like, yeah, I bought better tech, so I don't have those issues. So cool, easy solution. So let me touch on what I think is the most interesting here, which is that there's too many hard-coded rules. This is a bit sciencey, so get out your pens and pencils. So this is an artificial neural network. This is like what a lot of the neuroscientists in the room maybe believe a model of the brain looks like. But in computer science, these days, neural nets are hype, interesting, and we use them for all sorts of things, and I'll get into a bit of that. Each of these is called a neuron. So these are neurons. You have some inputs, so these could be numbers, and you have some outputs, which would also be a number. These neurons could do some function to translate your inputs to your outputs. So, like this is x1 is a variable, x2, x3, and you have outputs, y1, y2. This is like classic mathematical definitions of functions. And what we're trying to do is find a function that maps your inputs x and w, which is each of these connections, how strong each of those connections is. So like how strong each of those neuronal connections are, if I can use those terms loosely around a bunch of neuroscientists, and maps it to a function. We're trying to map inputs to outputs. That's all an artificial neural network does. Cool? So this is a simplified version because we're actually going to go through the math of neural networks now. You have some inputs, x1, x2, that are going through these weights and giving you an output. So a training example might be like, x1 might be the number of hours that I slept last night, and x2 might be the amount of food that I ate yesterday, and t might be how good I was feeling today. So I'm trying to find a function that maps how much I slept, how much I ate, to how good I feel today. That's some complex nonlinear function probably, but there might be a relationship. So I have a bunch of examples, because I track everything for 2 weeks, because I'm trying to find out if there's a relationship. These t's, these are targets, and I'm trying to estimate y, which is the function. So y is our estimate. This is our error function, which just takes the difference between a target and the approximated value of that output. This is just I define the error function, that's fine. And it's like the squared error. The outputs of each of these neurons is just the sum of all the weights going in and the output. So this activation function, this is the neuronal activation function, and this tells us that we can like calculate what the y is based on these activations. So each neuron has an activation. We use it to compile it. Come on in.
Hi.
It's the good part.
Are you waiting for John?
No.
Oh.
Are you?
Sorry?
Are you?
Oh no, he's just supposed to give a talk in one of these rooms. I'm just helping him. I'm not sure which room he's supposed to be. But sorry to interrupt.
Ladies and gentlemen, this is the robot. It's John. What if, hey? That would be a home run. So what we want to do is then take each of these training examples and update our weights so that we can approximate the function appropriately. This is a bunch of math. Worry first about this. This is our activation function. So like each neuron has a threshold. Once it reaches the threshold, then it activates. This is called a sigmoid. We want it to be nonlinear and differentiable. So like smooth and nonlinear. That's our activation function. For each training example, we want to update the weights by gradient descent. That's like a classic algorithm that's used in a lot of machine learning. And it just tells us that the updates to each of those weights, each of the W's here, W1 and W2, this simple little network, is just equal to this learning rate, this little a, which is a learning rate, and this term, which is the partial derivative of our error function, with respect to each of those weights. After some fun math, that's mostly just following the chain rule from calculus, we get this update, and we have a nice update. And this is pretty much fundamental neural network math. This is all you need to know. If you want to know neural networks, you have a leg up now. You have the whole story. So with that knowledge now, we can look at some different architectures of neural nets. So this is like maybe the most simple architecture. We can have more complex architectures as long as everything is nonlinear and differentiable. So here's an example, a nice easy example. This would be like a convolutional neural net. So say you had a bunch of pictures, a bunch of photos, and you knew that in each of the photos you had like a chicken, a dog, a cat, an elephant, rabbit, whatever this thing is, and you were like, man, I wonder what is in this picture. Well, you could train a neural net, a function that maps all of these understanding of these inputs to a function, maps all these inputs to a function, and then throw your input through that function. And it might have layers. It might have layers, like your retina has layers, like your brain visual motor processing has layers. So there might be some like edge detectors, and then there might be more like dog-specific feature detectors, like is it his tail or his paw or his like butt or whatever. And then it might run through some like activation, some top layers, and say, yeah, like, you know what, this looks mostly like a dog. So this would be one reasonable way that you would train a system to try to predict what animal is showing in an image. And it's not crazy, this is like critical stuff that Facebook and Google do all day, every day with huge amounts of computing power. So it's not trivial, but it is like easy to look at like this. Convolutional neural nets, because we're looking at image data. Image data has like 2D image pixels, and we can look over it and see if there's these features that we want. Cool? So what if you just have text? What if you just have like text-based data? Well, you could train your neural net to try to embed words in a space. So you take a big corpus and you train your words, put them in a space, so that words that you want to be closer together in that space are close, and words that you want to be further away are far away. So that backpropagation, you set your error so that your similar words syntactically or semantically would be closer together in this big space. So this is some like really cool work on word embeddings that puts a bunch of words from a corpus, from a big dictionary of words, into a space where king maps to queen in the same direction and way that man maps to woman. Or that walk and walking are linked in the same way that swimming and swam are linked. So that we can have like syntactic or semantic meaning that's embedded in this hyperdimensional space. Cool? So with this word embedding, now we have a bunch of words that are in this big space that are represented in this multi-dimensional space. We can start to do things like predict what word comes next. So maybe we can define our loss function to try to figure out what word is most likely to occur next. The cat sits on the mat would be the most likely to occur against all these other candidates if it was the one that occurred most often in our training. So we have a bunch of training samples, and the cat sits on the mat, or on the mat is the most likely to occur. We can also predict like how likely mat is to occur. And we can train our systems to start to predict what comes next. There's important sort of things that fall from this. Namely, two interesting ones. One is like, we can train these networks to start to predict what the translation of a line of text is going to be. So we input, each of our inputs is like a word, an embedding. We can't just input like words randomly into these networks, because words are like words, we need numbers to deal with. So we embed this in a word space, that big space of embedding, and then we can throw it into the network and pass it along and start to train it to translate. And this sounds like far-fetched and crazy, but this is how Google Translate works now. They just released like another paper and a big blog post, which makes it all interesting and fun to understand, that shows that this is a nice way that you can remember what you've talked about and not just predict the next word, but have some like context about the whole sentence. Because it's not just directly, I don't know who in here knows French, but it's not like a one-to-one mapping is the most easy thing to see. That like my doesn't map directly to my. They're kind of linked. And this is called, these are all based on LSTMs, and I'll get into what LSTM is. The other thing you can do is like embed these words along the way. You can encode them to try to predict what a topic is going to be. And this is critical because Piggy wants to stay on topic. As we're doing a scene, we want it to stay on topic. So you could do something like embed a full email. Along the way, you have a vector representation of an email, and you can predict what a reply is going to be. This is all based on your data set. So your incoming email is all represented in this big vector space, and you can predict what the reply will be. So this is based on this like fundamental work by Schmid-Huber, who's an interesting character in the field of deep learning. And pretty much this long short-term memory is like fundamental to dialogue because it allows for systems to remember things that have happened in the past and how they affect the current context. That's the good way to think about it, which may or may not be how humans act or we make decisions about what to say next. And this is like quoted in the New York Times, I think, that these big companies are using LSTMs as fundamental components of core products. So like huge companies are implementing these right now as ways to predict what humans are going to do, what words they'll do next, how to give an auto reply like Google, like you might use on Google, or predict what word will come next as you're typing an email on your iPhone. So Piotr then, to get back to the improv story, sends me this video. This is him with Albert, as Albert. So he's in character as Albert, performing alongside his embodied cognition. That's Alex sitting on a stage. This is July 24th. He has a good show, it's fine, it's interesting, but there are a few issues that he notices. One is that the character always has a single voice. So it's always set to like Tom on the Apple speech synthesis. The other one is that staying on topic is difficult. Well, there's an easy solution that the Apple speech synthesis has multiple voices. Can we like modulate its voice based on what you say in a certain way? If you give it a name, can it use that name to like link to the right voice that you want it to say? If you say Cynthia, then can it use the voice called Cynthia on Apple? Could it also like make nonverbal tics and sound more natural? Could it also play multiple characters? There's no reason that it shouldn't be able to communicate as this character, Cynthia, and also as this character, Brad, in this Brad-Cynthia hilarious scene where we all go to the mall. Also, staying on topic is difficult, but we know from all this deep learning that we should be able to model a topic along the way as we're having a conversation, and that maybe we can reward it for staying on topic. That like, we could give it some insights or some information that like, yeah, you're doing a good job, you're staying on topic, and I'm staying on topic too, which means we're currently having a conversation. These are the like natural human things that we do all the time that you sort of have to allow for a computer to do. Also at this time, I go to Austin, Texas to try to visit Arthur Simone, the character that you might have forgotten. And he's like, hey, I'm throwing a bot party hackathon. It's gonna be super fun. There's like lots of different people coming. And I show up and this is what it is. And here it says, call Arthur. And I go in and it's actually pretty cool. There's like a bunch of, you know, nerdy hackers sitting in this cool garage space, and they have stuff like this that's like, science! It's awesome. Needless to say, they're doing a lot of facial modeling. So when we have Piggy's face on screen, rather than just the lips moving up and down like a South Park character, it can actually like make shapes with its mouth as it's projecting its speech through. So cool, that'll be a fundamental component. Interesting, but altogether maybe not the most interesting. September 21, Albert and Alex perform again with all these improvements that we've made, and it is great. It's a great show, it's very interesting, but there still are open problems. The open problems are the bot doesn't know how to start and end conversations or scenes. So in improv, we're trained that like you have to set a platform for a scene, and then from that platform you can continue until you have to find a resolution. Cool? There's open and closed domains. So in improv, you usually get a suggestion, and then you stay sort of centered around that suggestion in the universe. And if you go to the aquarium, you're talking about the fish, and all of a sudden your scene partner says like, our planet's being exploded by Martians, and like it feels out of the universe. And that's something now that Albert and Alex have encountered. Yeah. The other thing is, could we embed conversations further? We know that we can like embed things in neural network representations. So could we embed a full conversation and say like, how good was this conversation? This is the idea of end-to-end training. There's also fixed knowledge. So this recent paper came out and they're like chatting with chatbots, the state-of-the-art chatbots, and they do stuff like, where do you live now? I live in Los Angeles. In which city do you live? I live in Madrid. So it's like obviously directly contradicting itself immediately after it says something. And to us as humans, it's like, that's illogical. Why would you possibly do that? That seems so easy. But for it to sit on knowledge and hold knowledge in like a temporary store is rather difficult. We also don't have great ways to evaluate dialogue systems. So like this most recent paper, March 2016, came out and it was like, how not to evaluate your dialogue system. which has a bunch of reasons that the current evaluation metrics are not great. We need better evaluation metrics. One of them probably is like specificity and uniqueness. That's an open problem. And we probably need better training data sets. So Alex right now is trained with open subtitles, like from movies, a whole bunch of lines from movies. But this one comment on Reddit really changed the dialogue world, because he was like, I have every Reddit comment. Does anyone want that? And then it like really took off, and it was really interesting. So maybe there are some dialogue hidden inside of all the like shit of Reddit that would be interesting to train on. It's also like way more than what we have with open subtitles. And it's cleaner, and it's actually humans that have written it as opposed to like automated systems that have pulled out subtitles. Also, I think that like plot is a big thing, so we need to be driving on plot. So this is 1919, when another crazy scientist is like, hey look, I made a robot and it can give you plots. But really what he did is like take the 8 elements of a story, of which now I think we just say there's 5, but he says like background, character, obstacle, problem, predicament, complication, crisis, and climax. That's like every story can be summed up in those components, and his robot, I put in quotations, because we maybe call robots differently than they do, can like mash things around, and there's 10 million different combinations that it can come up with as a plot. And that inspired this guy, William Wallace Cook, to create Plotto, which is a cool book that gives you such interesting plots as A, which is a character seeks wealth, his by right, which has been concealed. And then additionally, the plot point is A seeks wealth, which his father, the father of A, has left him, but concealed in a place whose location has been lost. Ooh, interesting. And then it gives you like a choose your own adventure, some like good places to go if you want to continue that plot. So realistically, we could give plot embedding to Alex and have it follow along and generate dialogue in each of these plot points, which would be a way for it to like contain the dialogue within plot points along the way. So then, September 19th, 2016, so we're like coming up on just a few days back, Google is like, okay, well, we've got a solution to voices and how they don't sound natural. They trained this super deep neural network with a bunch of hidden layers, very deep and very wide, with features, really precise features, like 16,000 features a second. And they can generate dialogue. Based on a bunch of training samples, they can generate dialogue. And it's dialogue that sounds really interesting. Oh, I don't know if we can hear it. Okay.
The avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
So that's one of the voices that they made.
The avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone. The avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
Right? So they have this ability to create a bunch of synthetic voices in a continuous space. So they're no longer limited to like the Cynthia voice that the Apple system has. They can generate it live on the fly. They also can give those like nuanced ticks to the speech, so it sounds like they're smacking their lips, or you still also have to give it something to say, and so they ran the experiment of like, what if we don't give it something to say? And you can listen to it on that website here, and it just sounds like mumbling, like a baby just kind of like Googling and blabbling and taking deep breaths in, because those are all like, you know, nuanced parts of speech that we don't think about training our agents on, but make it sound very human.
The avocado is a...
Oh God, that was about to be terrifying. So before this talk, I was like, "Hey Alex, I'm doing this talk about you later on. Like, can you give me some advice?" And it said, "Tell me something more. It's a bit too much. I would do whatever they wanted," which is great. It kind of fits. So I hope that this was an interesting story to sort of hear. I would love to, if I have time, like try to demo Alex. And yeah, that's me. I appreciate it. These are, you know, answers to questions that you might have. Okay, cool. Okay.
Is there anyone that has a question while he's programming?
Yeah, why not?
So the movie Sunspring, the recent movie, the sci-fi movie written by an AI,
Yeah.
which was fed tons and tons of scripts,
Yeah.
very similarly to the way Battle works here.
Yeah.
Is that an eminently different problem than the sort of dialogue-based one you're talking about, the improv one?
No, not totally different, but it's closed, and it's actually more of a suggestion-based system. So assuming that you're a plot writer, movie writer, and you want to like write a movie, you could have an AI system suggest a bunch of things to you, and then you could select the best candidates. And that movie was written in such a way that like the AI system would give you some candidates, and then you'd select the best one. There's a good writer for Clickhole, if you're into that internet, hole. And he does that. He writes articles with a bunch of suggestions. Yeah?
Sometime in your talk you said there were problems with this bot, Alex, then you launched into LSTMs and all of that.
Yeah.
And then you came back to Alex and said, look, it works better now. Does that imply that you actually implemented LSTMs and all of that?
Yes. Yeah.
Okay.
So the actual architecture of Alex is a deep, wide LSTM
Okay.
with multiple layers, and it also has a big chunk devoted to topic modeling. So it's trying to model the conversation that you're having along the way. So I think it's some amount of features, 500 features in a word embedded space, and it's trained on 1 million words, which is way more than we would actually use in natural conversation. And there's 64 units devoted to a topic model, and the topics are sort of derived and human labeled. Yeah. Yeah.
A lot of the problems you're complaining about are problems that humans have. Like, I can't stay on topic, for instance. If you listen to actual conversation, they kind of meander and they jump. And my 6-year-old son would give you a different answer to where he lived, depending on the precise wording of the question.
Right.
If you ask the same question again. So I wonder if you're trying, I always wonder this about AI in general. If you're trying to solve a harder problem, and on the flip side of that is, again, maybe it's still too much hard coding. Maybe topics should not be modeled so as things. You talk about short-term, long-term memory. That's stepping on my toes. Memory is scale invariant. That's the first thing you notice.
Yeah.
It's very hard to find a characteristic time scale. So if you make a scale invariant artificial memory, you're probably going to do better in the long run if you can get it to work.
Right.
So
right now,
by meandering off
yeah.
multiple topic jumps.
Right now, it feels like there are no ways to test if it retains entities, which I think would be fundamental, that we all have some ability, and that makes it maybe a little bit more human, but I don't know. Yeah.
I guess that's what I'm trying to.
That there
so
is.
What's the standard? Even this, you're already kind of hit on this problem, which is the corpora that you're using.
Yeah.
Are usually cleaned up, and because linguists clean stuff up so they can analyze it.
Yeah.
But now linguists are also interested in the messiness. But then what do you do with that all? And are you really going to be impressed if you make an artificial whatever entity that says I'm a lot,
right.
like I would? Is that really, you know what I mean?
Yeah.
Like there's this kind of weird kind of contradiction between the various multiple goals you could have.
The goal for me is always, can I do a scene with it? Can I do an improvised scene? So that's like a 3 minutes, no context. We get context from the audience that's like, you're cowboys. And then we have to like immediately set up the location, where we are, who we are, what the problem is, and how we're going to handle that problem.
Yeah, so it's hard for your bot, but it's also hard for
humans.
For me, for someone who's not an improv, you have to train on that. You have to learn the rules. You have to learn like how to end the scene, for instance.
Yeah.
That's something you have a standard, you agree on it. You know what I mean? Like that. Why should that be easy for a bot? It should be very difficult.
And it is. Yeah. So I wonder if there are ways that we can reinforce it to open interestingly and close interestingly with implicit reward. So one of the ideas that this guy in Facebook has is that in your dialogue, you can give a lot of implicit reward. This is like an August paper that he says like, oh, good answer. Now let's continue talking about this, which is like an implicit reward that the system can hear and think like, oh, that's something good that I said, and I should continue it around that universe in this high dimensional space. Yeah.
We chatted about this in Austin, and we had a little bit of a disagreement because I was like, it should say no. It should say no to things.
Right.
And because you're training it to do improv, the rules of improv are generally say yes to everything. But in reality, you have to say no occasionally to build conflict or to build story.
Yeah. And
how do you, if you have you solved that, or do you see that being possible? Because it's an interesting point about it's not conversation. It's it's improv. It's a totally different thing.
Yeah.
Not a totally different thing, but it's a bit of a different thing.
Right now, it has no idea of what yes and no is.
Mm.
It can sort of pick up when I'm asking a question, and then give an answer that's like a yes or no to that question. But there's no concept of no yet, so maybe an implicit feedback would allow that, but I don't know how to model that.
And I guess not to keep people from the demo, but the other thing was in terms of embedding words.
Yeah.
It's, for me, that like triggered the idea of humor, more so than like understanding what should go next. It's like it puts you in this realm of like, oh, we're talking about royalty, so king, queen, that much I get, but also I'm going to make a reference to you're such a court jester, or you're such a, like you're the king of the castle, aren't you? Where those types of references will make sense to it.
Yeah.
Do you see that humor element coming out in that word, sort of embedding stuff?
Not exactly. I think humor is the hard concept, but there is a sense of how far away from that embedding you're going to jump. That's something, a parameter that we call temperature here. So here it gives a bunch of candidates, and then it's going to pick a candidate with some probability that has like that it prefers. And it might prefer something that's closer to the universe that it's currently living in.
Cool.
But the idea that there are more funny subspaces is really interesting.
Yeah.
And I think that's true, that people think that words are more or less funny, and that we could probably embed that space.
That part really was really interesting to me from the humor standpoint, because I can say like, you think you're great, don't you? But if I say, if you're the king, and we've already established that, and I say, you're on top of your spire, aren't you?
Yeah.
That's like a reference to the joke that you've or the setup that you've made before.
That's great.
And like really connects it to like, and that's really, it's not just conversational, but it's actually improvisational.
Yeah, I
Right.
like that. I like that one. Let me try this. Let me try and see if this is going to work. I have Alex running here. This is like some tests that I did. I'm going to start it and then give some dialogue. I hope that the sound is going to come through. And like any live demo, we'll like pray to the demo gods that there's something that worked. So like, what's a topic that I could like give a seed to about it? What's a place? Anything?
Washroom.
Great, love it. Love it.
Classic.
Cool. Start improvising. Okay, check. We're here in the bathroom. We gotta clean up these toilets. I mean, did you bring your plunger? We got a real mess on our hands.
I am no. Sure you do. I don't.
Okay, I mean, I'm gonna start cleaning, and if you want to help me out, just give me a hand over here.
I think we should clean up a little while longer and you might be able to get in touch with us.
I agree. I think that like cleaning up these toilets really helps us connect on a whole different level.
And I want to see that's all I have to do.
Yeah.
Well, I am no. Going to stop for the health of my own sister.
I'll call it there, or else it'll just start to be worse than that. Yeah, I'd say like give it a round of applause. I mean, I think there was a minor success in there in that it said something about cleaning and health, maybe. Here are some of the other candidates. You probably saw them scrolling by as they went. But I think that was exciting. Thank you for allowing me to do it. I'm so happy that worked. Yeah.
So I guess coming back to this idea that improv is a bit different than conversation, and then trying to bring in reinforcement to it. I mean, isn't it the case, not being an improv artist, don't you actually react from what the audience has experienced? So can that not be a reward when people begin to laugh?
Yes, I love it. That's great. This is an idea that sort of came up, that it should be listening for the laugh, and it should be translating that as some kind of scalar reward signal and helping to reinforce it, make certain choices. The terrifying idea is that then, set it on a robot and then it starts to creep close to the edge of the stage and the crowd gets a little louder, so it like creeps a little bit more until it just like jumps off the stage. So yes, while that's a hilarious, crazy idea, I think that it should be listening to the crowd, but right now there's no way for it to know when I'm talking, and that's like a conversational piece versus when the audience's reaction. And I don't know how to model the listening of the reaction.
2 microphones.
Or you give everyone a
dial.
The problem is it's like feeding yourself fat and being like, oh, my body likes this, I should just eat more fat. Because you don't only want the audience to laugh, you want them to also feel and think and make connections, and those can't be picked up by a microphone.
Yeah,
so if you teach it only to laugh,
I just love to see a computer own Kory.
Yeah.
Yeah, me too. How's it gonna beat me? Yeah.
Maybe this is hard to answer, but where would it have drawn Sister from? Because in improv we talk, that would have been a part where that would have been like a reveal, that would have been giving more information, that would have changed the scene, yet that wasn't connected to what had come before?
Yeah, I mean, it seems like it was, it was the best, answer.
Cool.
So I think it's because there was health in there. Mm-hmm. It also drives more towards relationships, on principle, but it's hard also to evaluate. This is exactly the thing, is that it's hard to evaluate.
So is it still drawing from just like tons of data it's drawn from other places? So that is like a little nugget of something it has heard once and is now regenerated.
So it's not, this isn't a line that it found anywhere in an open subtitle. It's generating this word by word.
Cool.
Yeah.
Weird.
Yeah. Yeah.
So maybe this gets back to the question about that Julia had about humor, and maybe that was Julia or maybe it was someone else. But I was under the impression that some ideas of how humor is funny is that it disambiguates an ambiguous situation, and so and a lot of the reason we all laughed is because of how ambiguous what he was saying was, or she. Or it, and almost if it was more on topic, it would be less funny. It was just like, yeah, let's clean the bathroom. But as soon as there's a sister, you're like, what does that? I want to know about that connection.
Yeah.
It's like that snap, either disambiguating or creating ambiguity, that might teach us something about humor by knowing what people think is funny that Alex says.
Yeah, I think that there's 2 pieces. One is that a lot of the ambiguity theory of humor could be seen as like, it could say anything right now. It's an AI, no one knows what it's going to say. And then it says something and we're all like relieved that it like worked and like Kory's not going to be sweating up there. But this is the reason that like chatting with Siri on stage isn't very funny, because we all kind of know deterministically what it's going to say. In some ways it has hard-coded rules, but because there's some randomness to it, that's interesting. I also see performance with this like performance with that guy, the random dude, is that like, I just want him to say anything, and I trust myself as an improviser to know that I can make it make sense, or I can like derive meaning from it and add my own layers to it, try to make it look good. So when I'm performing with it, I'll do things like, oh man, like what a tough day, we've been working here forever. What's that thing that your dad always said about tough days? And then it'll say something random like, we have to stop the whole thing. And it's like, great, I set you up with an easy question that you can answer in any way.
Okay, as a follow-up then, not to scare you, but it might be funnier for us to just hear one bot talk to another bot at that point, eventually or something, and then you can just sit in the audience.
Yeah, what if the whole audience was also bots?
And so it seems like then there's something that you do differently than another bot would do, that you keep trying to bring it back to our common knowledge in the room, and kind of bring it down to earth every time it gets a little bit weird.
Yeah, one of the things that I have that it doesn't have is like all of your eyes on me. I can see who's listening, what they're doing, and I can inflect my voice to change your attention or perception of what's happening. And it can't really do that. It can't see you yet. It can't really hear you yet. So we're just interacting, and I'm the interface. Yeah.
I'm just curious, when you were giving the inputs, like it wasn't translating sort of what you were saying perfectly. And I'm just wondering, because a lot of the humor seems to come from just like non sequiturs that the machine sort of creates. If it's
like
inputting your responses more accurately, is it as funny?
Yes, it's a level of noise that we inherently have to deal with because speech recognition isn't great. I can run this same demo but just type into Alex's brain, and it's interesting, and I can spell things the same each time and stay on topic, but even if I'm typing, I'm going to make mistakes, or my grammar's going to be off.
Is the difference in terms of the responses that get output, is there a substantial difference, or is it roughly the same?
I think it changes how I interact with it a little more. If I'm typing into here, then I'm doing it like I'm in a chat room, and I sort of slowly take my time. This one it's timed, as you can sort of tell. It needs things to happen in a certain amount of time or else it'll trigger an action. But if it's just text-based, then I can sort of take time and try to relink things so it could be more precise, I think is what maybe you're asking, and yes, it is. So I would love to be able to deploy it as like a service online that people can type into, and it'd be interesting to model those discussions.
Any one more question before we all go back to our boring lives?
In our alone time. But if you wanted to keep it on topic, why wouldn't you just kind of have it set up so that you're talking to the audience and you're like, hey audience, where are we right now? And then Alex can just hear where we are, location. And then you say, hey audience, who are the characters here? And so give it all the elements of a plot.
Yeah.
Where you trigger it, like, what are the characters? What's the conflict? What's the resolution? Blah, blah, blah.
Yeah.
So it would stay within the realm of the world, or at least it would trigger.
Right now there is a bit of that, and I'm being mushy a bit about the details, but there is some of that. So in the first thing that I said, I mentioned that there was a place that we're in,
right,
and maybe a bit of a relationship.
Right.
So in that opening monologue, it's trying to derive as much of that information as possible. It's not as distinct as like, who am I, where am I, and then filling entities, because it can't really hold on to entities.
Oh, so it just can't.
Very well. Yet. That's a great question. Yeah?
Is that a question?
No.
Okay. Thanks everyone for coming. Next week we're going to have Chris Westbury talk to us about the neural correlates of something.
Concrete and abstract words.
Concrete and abstract words. So kind of looking at this from the other side, from a neural perspective. And I hope that you can all come. There's a website. I'm going to set up a mailing list. If I guess I'm not bothering you guys, but the people that aren't here that don't want to get the mail anymore, that will help them. Thank Kory for coming.
Yeah, thanks so much.